Hey everyone, so today we are going to continue solving systems of equations, but instead of inverses, we are going to have identical terms, and we're going to take a look at two different methods that you can use for solving systems of equations that have identical terms. Okay, so solving systems when given identical terms, method 1. And this is the method that you will see if you watch the Delta Math videos. When terms are identical, we're going to multiply one equation by -1 to create a pair of additive inverses and then solve it as normal. So as we can see here, we have y plus 8x equals -16, and then y minus 3x equals -5. So we do not have a set of additive inverses. So we need to create a pair of additive inverses so that when we add the equations together, those inverses are going to cancel out. So I see that I have y and y. These are our identical terms, and I want one of them to be negative. So what I'm going to do is I'm going to multiply an entire equation by -1. Now, it doesn't matter which one you multiply by -1. Either way, it'll work, but you have to multiply every term in that equation by -1. So I'm going to multiply this bottom equation by -1. It's supposed to be parentheses. I'm going to put the entire thing in parentheses. And I'm going to put my -1 on the outside, and I'm going to distribute it to every term, including this -5. And I'm going to rewrite my new equation next to it. So -1 times y gives us -y. -1 times -3x. Negative times a negative is a positive 3x. And then we get -1 times -5 gives us a positive 5. Okay, so now we can see that this y is now negative. I'm not going to do anything to this top equation, so I'm going to just rewrite it on top of our new equation, because I like things to line up. Makes it a lot easier if you stay organized with these kinds of questions. Okay, so I just rewrote this equation here. So now we can see we have our additive inverses, and we can solve it like we normally would as we did yesterday. So the next thing I'm going to do is identify my additive inverses, which is this y and this -y. And then I'm going to add these equations together for these to cancel out. That's the goal. So if that's not happening, if something isn't canceling out after you do that first step, then something's wrong. 8x plus 3x is 11x. -16 plus 5 is -11. Then I'm going to divide by 11 on both sides, because I want to get that x by itself. So we get x equals -11 divided by 11 is -1. So x is equal to -1 here. Remember, there's two variables in this system, and we want to solve for both. So now we need to solve for y. So we're going to do the same thing that we would do before. We're going to plug in our variable into either one of the equations. Just do not plug it into the new equation that you created. Because if you made a mistake, then this equation could be wrong, and then that's just going to lead into an even more incorrect answer. So plug it into one of the original equations. That's a really important piece of this. So I'm going to do that over here. And I'm going to just use the first equation because I didn't touch it. I didn't change anything. So I feel like it's just easier to use that one. But you could use this one if you wanted to. This y minus 3x equals -5. Equals -16. And I'm going to just plug in what we know for x into our x in our equation. So right underneath it, I'm going to put parentheses -1. And then everything else is going to stay the same. Bring down the y. We don't know what y is. That's what we're solving for. Bring everything else down. Now solve as you normally would. Let's do the multiplication first. 8 times -1 is -8. So when we multiply these, we get -8. Bring down your y equals -16. Now let's add this 8 to both sides. it cancels. Y equals, and then negative 16 plus 8, different sign, subtract, keep the sign a little larger, so that's going to give us negative 8. Don't forget to write your answer as an ordered pair. X comes first, then Y, so our answer is negative 1, comma, negative 8. Okay, so this was method 1, where we took one equation and we multiplied everything by negative 1 to create those inverses. We're going to take a look at the next method right now. Okay, so solving, same thing. We have identical terms. Method 2. So when terms are identical, we can also subtract the equations to cancel out the identical terms and then solve as normally. So instead of distributing a negative 1, we can just subtract everything. So that's what I'm going to do here. Okay, so I'm going to put a subtraction symbol. Oops. Okay, so we have negative 2 minus negative 4. So be careful with these negative signs. They can get kind of messy. If you want to write it somewhere else, and then we can always erase it. Negative 2 minus negative 4. We can see keep, change. So we're really going to add these, and that's going to give us positive 2. So I'm going to get positive 2x over here. Now, negative 9y minus negative 9y. You can do the same thing if you want, negative 9 minus negative 9. I'm not including the variables here, just to show the arithmetic of this. That would become a plus sign, and that's going to give you 0. So, whenever you're subtracting identical terms like this, they cancel out. They're automatically going to cancel out. So you don't have to show that on the side if you don't want to. I just wanted to show you why they're going to cancel out. So that would give us 0. Those cancel out. And then negative 25 minus a negative 23. That would give us, oops, that's a 3. That would give us negative 2. Okay, so I'm just showing that subtraction on the side. Sometimes you're going to have negative numbers like this, so it's definitely important that you know exactly how to subtract these negative numbers. Okay, so I'm going to just take a minute and erase this because we're going to need this space. Okay, and let's continue to solve. Divide by 2 on both sides. We get x is equal to negative 1. Okay, so that's the first part of our equation. So you can see there's a lot less, obviously multiplication here. Sometimes the numbers will be a lot easier to work with. I just wanted to give you a more complicated example so you can see exactly what it would look like. But now let's solve for y. Okay, you can choose either equation, doesn't matter which one. I'm going to choose the first one. And we are going to substitute our x value in. So now instead of writing x, I'm going to write negative 1 where x would be. And I'm going to just bring everything else down so we can solve for y. Oops, that's a 25, not a 23. Okay, so we multiply this, we get positive 2 minus 9y equals negative 25. Subtract your 2 on both sides. Solving a regular equation. Just move this up. We get negative 9y equals negative 27. Divide by negative 9 on both sides. And we get y equals positive 3. Don't forget to write your answer as an ordered pair, x comma y. So we have negative 1 comma 3. So either one of these methods will work. They're both the same premise where you're canceling out one of the variables, so you can just solve for one at a time. You can use whichever method you're more comfortable with, and you can also decide what method you want to use based on the equation that you have. Okay?